All right, so now everyone should be able to graph a sine graph. If you don't, I don't know how you did the test yesterday. I mean, really, like how can you graph a secant or cosecant graph without knowing sine graph and cosine graph? So, oh, by the way, I have a correction to make. Previously, I said that after yesterday's test, you can wave goodbye to secant graph, cosecant graph. I forgot that there was a progressive part of test 2. So, so just hold on to what you had already. And if you did not have it, then make sure you have it before test 2. Right now, so right here, okay. So I'm trying to draw this. Let me see if I can draw all the points right here. So we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then we have pi over 2, pi, and then 3 pi over 2, and then 2 pi. And trying to keep the graph nice. I'm going to duplicate the axes right here. So now this is how I would do. I want you to get into my mind. And I actually need you to get into my mind today, because I was kind of clueless when I learned this. Not this, but the stuff that I'm about to introduce to you. So for sine x, as I said, you should know that it starts from the origin. If you don't remember this, then just ask yourself, what is sine 0? 0. That should give you a confirmation that, oh, sine graph should start from the origin. And then should have an amplitude of 1 and negative 1. So then you know how to graph those 5 points. And then you can trace backward of all those points. And by now, you should know that these graphs will keep on going, right? These graphs will keep on going. So for cosine graph, y equals to cosine of x. So it starts from the highest point. Okay. Oh, actually, starts from the highest point. Let me copy this graph axes first. Starts from the highest point and then 2 pi. So I sincerely hope that you are really familiar with all these simple graphing of parent function. I hope I'm not drinking Kool-Aid just to believe in something too idealized. I have strong faith in you that you know how to do this kind of stuff. All right, now everyone should be able to produce something like this. And now the question is, I would say, guys, I want to show you something. Can you see now? If I say this to you, okay, I want you to label this too. Can you see from here to here? This is quadrant 1. Can you see that? If you see that, you can go ahead and label it. Can you see that from here to here, it's quadrant 2? Because it's from pi over 2 to pi. So I'm not talking about the whole graph 1, 2, 3, 4. I'm just saying based on the x values. Can you see how this is quadrant 1 and this is quadrant 2? Okay. And let me go backward a little bit. Can you see this is quadrant 4? Okay, can you see that? Because it's negative pi over 2 to 0. So we're going backward, negative pi over 2 to 0. And can you see this as quadrant 3-ish? No, not ish, quadrant 3. Negative pi to negative pi over 2. And we can keep going, of course. All right, but I'm not going to spend too much time. I just want to make sure that you know how to read something like this based on the x values. And now I hope you can focus on this. I really hope that you can focus on this. Okay, you can stop doing anything that's not math related for a moment, just a moment. I'm going to ask you a couple of questions. First, look at these two graphs. Are they functions? Are they functions? Well, yes, because we call them trig functions, right? But what's the real test that you can say, oh yeah, it is a function? The vertical line test. Hold on to that answer. Hold on to that. It's a vertical line test. It only cuts the graph once, so it is a function. But now I want you to ask yourself, I want you to write down this question. Are they one-to-one functions? Meaning that 1x to 1y and 1y to 1x uniquely matched up. And we say, no, we should go ahead. No, of course not. Now, I believe you have heard of one-to-one function in algebra 2, but I'm not sure if you realize the significance of asking this question, because I certainly did not understand why on earth we care about one-to-one function until I truly understand what the heck is going on with the idea of inverse functions. What's an inverse function? Anything you can think of, relate to. The opposite, right? Opposite, what's opposite? No, that's different. Reciprocal is reciprocal. Do you remember how to find inverses back in algebra 2? You will? Flip the x and y, right? You switch the x and y and solve for y again. That's how you do the what's it called? Inverse function. All right, that's how you find out if you have a cubic function, you find the inverse, it becomes a cube root function. If you have a square root function, you find the inverse, it ends up with a quadratic function. Now, there are multiple ways you can describe an inverse function. And the easiest would be, oh, you just swap the x and y. But what about visually? What about visually? Well, I'm about to show you how to see it visually. So this is the sine function, okay? So when we say switching x and y, well, you can either tilt your head, but that's difficult, so I'm going to help you out. You switch to x and y. Is it a function? Is it a function? We say no, of course not. It's not a function because if you draw a straight line, it's going to cut the graph multiple times or infinite amount of times in this case. Well, we have a problem because we want to find out the inverse function. We want to have an inverse that's also a function that would give us a single y value instead of numerous, infinite amount of y values. And therefore, we have to do something about it. Well, what can we do? Well, you touched on this back in algebra 2 when you saw for the inverse of quadratic function. And I'm going to say this here in case you forgot from last year. We restrict the function. Well, it's not a one-to-one function at this point. Well, then make it a one-to-one function. Well, how on earth can we do this? Well, so let's think about this. Well, you know, if you try to make it a one-to-one function, so that means you want to draw a vertical line that will not cut the graph multiple times. So just trim down the graph so that it won't cut the graph multiple times. Oops. So we say, well, let's only talk about this part of the sine graph. And which two quadrants are we talking about here? Quadrant 1 and quadrant 4. That's why we cared about one-to-one function back in algebra 2, because we want the inverse to be a function as well. If we don't restrict the function, then it's not one-to-one. And if it's not one-to-one, it's not going to be an inverse function. All right. Now, why is this important? I probably go more in depth than what I needed to compared to other teachers, but I think it's very necessary because I was dumb on this topic, and I don't want you to be like me. So now on the side, I want you to write something down too. Now I'm going to ask you to write down this question. If I ask you, okay, so sine theta, it's equal to 1/2. Please go ahead, find theta. What is theta? If sine theta is equal to 1/2, what is theta? So theta is pi over 6, 30 degrees, yeah. And what else is possible? What theta value would give you 1/2? Five pi over 6, right? Quadrant 2. Okay, ASTC, remember? ASTC, quadrant 1 and quadrant 2. So this is why we say you need to know your unit circle values. Okay. Now usually when we ask you these kind of questions, we will have a restricted domain. We will say, hey guys, you are going to just do this somewhere between theta. Theta is going to be between 0 and 2 pi. So just do that. So I was like, oh, that's easy. You think it's easy? Yeah. If you know your values, you got it. Now, what we're about to do is to have some notations like this. What does that equal to? Now think about this. If you use a calculator, if you do this, sine of theta, it's equal to 1/2. Like, do you actually know where did the sine go over here? Like, how come it disappeared? Do you know? Like, you wrote down the answer, but do you know where the sine go? Because in math, things have to have a reason to appear or to disappear. Where did the sine go? I'm going to blame your geometry teacher, actually. Because a lot of geometry teachers, they do not focus on this. But when I taught geometry back then, I focused this heavily. Because I want to make sure that students actually understand how notations work. This is what happened. You do the inverse sine of the sine function. They cancel each other out. That's the idea of inverses. They cancel each other out. And that's why on your calculator, you have sine function, and then you have the inverse sine function, right? So what you want to do to find out the, so if I have inverse, okay, pi over 6, let me see if it's in radian. Yes, it's in radian mode. So I would say, all right, enter. Oh, sorry, I should say, oh, no, wait, hold on. Oh, sorry. No, I would just say sine inverse of 1/2. That was 1/2. So sine inverse of 1/2, it's, no, sine inverse of 1/2. Pi over 6, yes. It's pi over 6. Now that's what the calculator tells you. And if you do the problem on the left, you'd be like, oh, that's pi over 6. That's a reference angle. And you need to make sure that you also account for the second quadrant. I think we did that before, last semester. We give you the value, we give you the ratio, and you give us the angle. We did that last semester. So I had that thought. I was like, oh, so this must be easy. So I wrote down it's equal to pi over 6, and then 5 pi over 6. Okay? Write this down. And I'm asking you to write this down because this is wrong. This is wrong. This is okay. This is wrong. And I was so puzzled. I was like, what? I thought if you have 1/2 ratio, you want to find the angle. So you have pi over 6 and 5 pi over 6. So why is it wrong? You know why I was wrong? Because I did not understand the graph. There was a big missing piece when I was in PreCal back then. I was not aware of the restriction of the function. If you restrict the domain so that it can be a function, it only shows the quadrant 1 portion and the quadrant 4 portion. And when I wrote down 5 pi over 6, that's in neither of these two quadrants because 5 pi over 6 is in quadrant 2. So 5 pi over 6, it's out of domain. It's not part of the included domain. So that's why it's not an acceptable answer. And that's why only pi over 6 is the answer. So when I did all these problems back then, I would always get one right and one wrong. And I had no idea. So now, let's take a look at the cosine function. So I'm going to see if you can take what I just taught you. So is this a 1-to-1 function? We say it's not. So, and let me go ahead and label the stuff out. So this is quadrant 3. This is quadrant 4. This is quadrant 1. And this is quadrant 2. So in order to create a 1-to-1 function, which quadrant or which quadrants should we keep so that it is a 1-to-1 function? Out of these 4 quadrants, now they have to be continuous. So you cannot pick quadrant 3 and quadrant 1, cannot do that. So which 2 quadrants, which 2 consecutive quadrants should we take so that it is a 1-to-1 function? 1 and 2 or 3 and 4, good. Very good suggestion. Either 1 and 2 or 3 and 4. And by practice, we always keep quadrant 1. That's easiest. So we just say, all right, now for the inverse trig function, for the inverse trig function, we don't need things from the negative side. Okay, let me just erase them. Okay, so we'll just keep the quadrant 1 and 2. So the cosine function, we will keep only this part, and then we will translate this to the inverse. We switch the x and y, and we graph it. Okay. So based on what we just discussed, let's see if you can apply this thought process. So if I give you a inverse cosine of -1/2, what is the result? And by the way, let me just emphasize one thing. Is this an angle or is it a ratio? This is a ratio. Remember last semester, I made a point. You've got to make very clear the distinction between a ratio and an angle. This is coming back. So what's the angle if you have a ratio of -1/2? So think about this. Now, I'm going to show you two ways of thinking through this. If you use the unit circle method, then you realize that it's in quadrant 2. X value, it's -1/2. What's the angle? Unit circle, quadrant 2, X value 1/2. What is the angle? 120 degrees, or in radian? (2π/3). Okay, so if you use the unit circle method, that's how you process the information. Okay. Now, if you use my table method, then you just stick with the reference angle. So you think about, all right, why is it negative? Well, it's negative because it is in quadrant 2. All right, we took care of it already. It's in quadrant 2. So 1/2. What's the reference angle for cosine to be 1/2? π/3. So reference angle, π/3, situated in quadrant 2. So you go from pi and you go back π/2 because in quadrant 2, no, not π/3, sorry. You go from pi, you go back π/3, so you end up with 2π/3. Okay, now I would say you probably need either one of these two methods. So pick your lane. Okay, make a decision. Any question on how we decide these quadrant restrictions?
No, if it's not in 1 and 2.
For the cosine, well, if you refer back to the ASTC thing, so cosine is positive in quadrant 1 and 4. It is negative in 2 and 3. But since we are restricting it to only quadrants 1 and 2, so that means if it's quadratic, oh, sorry, if it is positive, it must be in quadrant 1. If it's negative, it must be in quadrant 2 for the inverse. Okay. All right. So now we can quickly graph a few points here. So we have 1, and then this, and then this, and then this, and then this. And apologize for some misprints there. For some reason, the values are not really showing up. Like the pi, somehow they disappeared. Don't know why. So you have this graph that we drew earlier on the piece of paper. So we can keep going, but it's not really necessary. So we just ask you to draw from -2π to 2π, and you can just use the a highlighter if you have a highlighter, or just circle or box them. Okay, if you have a highlighter, you can highlight it. If not, then just kind of box this region. So, and make sure you give yourself a reason. Okay, the reason is this restriction makes this restriction makes a 1-to-1 function. Okay, and just like what you did in algebra 2, we'll swap the points. Okay, we look at the key points and we will swap them. So we'll say, all right, from 0 to the first point here, it's 0, 1. So that means we have 1, 0. And then we have pi over 2, 0 from the left, and then translates to 0, pi over 2. And then we have pi, -1 on the left. So that becomes -1, pi. So now the graph is going to look like this. So that's why earlier I used my way of showing you what the inverse function is, because with my iPad I can use that technology to rotate it without you tilting your head or hurting your neck. So you're just looking at this as a sine graph or cosine graph being graphed sideways. Now the good thing is we don't talk about a lot of inverse graphs, okay? But if you are in next door, you have to do all 6 functions and the inverses, which is a bit scary. I'd say a bit scary. And we do the same thing for sine x. Sine x is here. We start from the origin. And then I assume that you can speed through this graphing action, making points very swiftly. And again, we will highlight the portion that we restrict to. In this case, it's only quadrant 1 and quadrant 4 that we are restricting it to. So there was a moment in my life that I had no idea, 0 idea, why on earth we are restricting these domains. I had no idea, I just memorized them. Until much later, I saw the graph, and this is also the reason why I strongly advocate you guys to learn how to graph, because I had made enough dumb mistakes to not like graphing, and I don't want you to be like me. And by the way, I asked the calculus class next door at the early part of the lesson. I asked him, what do you suggest? Like, what? I asked him, is calculus hard? They said, yeah. And I asked him, like, what do you want to know? What would you say? That's something that you should learn well in PreCal. Unit circle. From them, your classmates, your schoolmates. Definitely unit circle. And something called trig identities, which we'll see next week. That's my favorite topic. All right, so here we see a graph. We have 0, 0 here. We can graph that point very easily. And then the left point right here, we have negative pi over 2, -1. So that means we have -1, negative pi over 2. And then we have pi over 2, 1. So we have 1, pi over 2. So, okay, just like that. Now, I personally have a question when I was trying to do this graph. I'm not sure if you are thinking about this too. When I was doing this graph, I would often challenge myself and ask myself a very simple question. How do I know it should be graphed this way? Like, is it possible? Is it possible that's being graphed this, like this? I was thinking about this to myself. And it took me a while to realize that it must be like this. So what's the argument that I can tell myself and you can tell yourself that this graph must be drawn like this? Well, I mean, the coordinates are just 3 points. So the argument is this. If you kind of rotate your paper or twist your head, can you see a cosine graph or sine graph? Okay, and that's the argument. If you do it the wrong way, like if you do something like this, and then if you twist it, you would not see the look of a sine graph or cosine graph. So that's how you know what is right and what's wrong. Okay. So let's fill in some blanks. So cosine theta, it's equal to √3/2. So the theta value must be unit circle time. If cosine theta is √3/2, it's in the first quadrant, so it must be pi/6. So we say inverse cosine, it's pi of √3/2, it's pi/6. Okay, again, you have to read it out loud in your head or verbally with your voice. And please, I beg you, please, that you know how to categorize these things. √3/2 right here inside the inverse cosine function. That's a ratio. Put that little bit of effort in there, it's going to make a huge difference. So if you have a sine theta, it's equal to √2/2, then theta must be pi/4. So sine of inverse of √2/2 is pi/4. Now, quadrant 1 is not that hard. I think the most challenging one is quadrant. When you see a negative value, then you need to know your quadrants. So that brings you to the. Well, hold on. Before I bring you to the next page, just go ahead and highlight this stuff right here. So we have 2 ways of representing inverse trig functions. We can use the negative one right here. And by the way, that's just a notation to show it's an inverse. It is not saying that it has a -1 power. Okay? They're not the same thing. So we can use a cosine with a -1 in the superscript location as the inverse cosine or inverse sine. Equally, we can say and write down arc cosine or arc sine. They mean exactly the same thing. It's just a way of annotating it. Yes. Say again? Same answer? Where? No. That's not theta. This is a ratio. Okay, so we're saying cosine of an angle. Cosine of an angle gives you √3/2. What is an angle? Oh, pi/6. So an alternative way of writing it and saying it is that inverse cosine of the ratio is what angle? That's why last semester I put an extra bit of effort to tell you guys that, hey guys, make sure you know what is the identity of those numbers. Is it an angle or is it a ratio? So now if you flip to the next page, then there's a little chart that I used to just tell students to memorize it. And now I would say, if you want to memorize it, sure. But I would really want you to understand the meaning behind the restriction. Why are we restricting quadrant 1 and 2 for all these functions on the left? Because if you look at the actual cosine graph, secant graph, cotangent graph, then you will see that restricting the quadrant 1 and 2 will provide you this inverse, this one-to-one function. Okay, now let's simplify the thought process. What's secant function again? Reciprocal of cosine, right? So now, so I would say you can group them together. Cosine and secant, well, they're together, right? And sine and cosecant, they're together. So you can minimize your memory space to keep all the information in your head. So the only thing that you need to know is that tangent and cotangent, they are different in terms of restrictions. And if you know how to sketch tangent function, if you know how to sketch a tangent x function, that would help. Because for a tangent x function, well, it's one-to-one. And all you need is just quadrant 4 and quadrant 1, because yeah, quadrant 4 and quadrant 1 would be the best, because if you need to take quadrant 2, then you have to pass through the asymptote, which is not very smooth. So quadrant 4 and quadrant 1 would be very straightforward. And then for cotangent function, if you remember cotangent function, you have the asymptote at the y-axis, and then it just goes down like this. So quadrant 1 and 2 will be a one-to-one function. So that's pretty much why. Okay, I want to emphasize the why, not just the what. Then you have a better understanding. It's just the extra step that you'd make, and it's going to stick in your head a lot better. Okay, so let's look at these questions. All right, so again, you have two ways to think about this, either using the unit circle method or my table value method. So for this one, cosine inverse of -1/2. So you think about x value, -1/2. And also, I would suggest you to write down the quadrant. What quadrant would it be? This must be quadrant 2. So kind of give yourself a little guidance so that you know what number you're going to write. So quadrant 2, so inverse cosine of -1/2 would give you a value of root, 2 pi over 3. Again, this is a ratio. We are asking for an angle. Okay, inverse cosine of a ratio gives you an angle. What about inverse sine of -1/2? So we think about, what quadrant would it be? It must be in quadrant 4. Okay, you can look at the table above if you need to you have some quick guidance, quick reference. And the y value being -1/2, what's the angle? So you go back from 0, so it's negative pi over 6. Now it's in quadrant 4, but we're not going to use 11 pi over 6, because if you go back to the graph that we had earlier for a sine graph, this is how we say quadrant 4. It's immediately to the left of 0. That's why it's negative pi over 6 instead of 11 pi over 6. And if you write down 11 pi over 6, it will be considered wrong, because that's not part of the restricted domain. Okay. Arc cosine of √2/2, it's equal to √2/2 positive. That means anything positive must be in quadrant 1. Anything positive must be in quadrant 1. So what angle will give you a √2/2 ratio? It's equal to pi over 4. So I kid you not. Unit circle, it's important. I do not care what method you use to retain those values. If you do not have those values in your head, and you're gonna have a headache. Okay. Now, I would like to go over something like this for part 3. Okay. Oh, degrees. I forgot. Why would you do degrees? Sorry, I did not see the degrees right here. So just cross it out. We use radians all the time. Now for part 3. Now what's going on with this? Well, it is sine of a angle. So you're trying to find out what the angle is so that you can get a ratio at the end. Well, arc sine of √3/2. What is arc cosine of √3/2? So it must be in quadrant 1 since it's positive. So to be in to have a √3/2, that angle must be pi/6. Okay. So it's an angle in quadrant 1, it's pi/6, and then now you ask yourself a question: what is sine of pi/6? 1/2. So if it's like in terms of difficulty, I would say it's not that hard if you know a couple of things: your unit circle values and your restrictions. If you have those two in your head, easy. Think about this. What about this one? Okay. So again, we have cosine of an angle, but this angle is kind of ugly. So let's take out this angle first. So this angle, it's well, sine inverse of negative √2/2. So it must be an angle in quadrant 4. It is negative pi/4. Okay, to have √2/2. And cosine of an angle in quadrant 4 gives you a positive value. So cosine of negative pi/4 is equal to √2/2. Okay. So that's really straightforward. Okay. Now I'm going to continue part 4 on Monday. So on the worksheet, I would urge you to finish 1 through 22. 1 through 22, please go ahead and do that. And then we'll talk about 23 and onwards for next week. So it's pretty straightforward. So if you understand why we have a restricted domain, you are in pretty good shape. And we need to restrict our domain because this original trig function is not a one-to-one function. So therefore, the inverse will not be a one-to-one function. So we have to restrict it. And then we have an inverse function. Okay. And then we have an inverse function. So Monday, now I'm going to ask you something on Monday. I will ask you all the restrictions. Okay. Expect that I will have a chart for you, like inverse sine, inverse cosine, inverse tangent, all those 6 functions, inverses. And then I ask you to write down the restrictions. Okay, and by the way, what's going to happen on Monday? Unit circle quiz. Now, I haven't seen a lot of people practicing using the Schoology stuff. Please do. Yes. Same as last part, but you cannot draw a circle. And you'll be done in pen.